So we have another example where we're going to rationalize the denominator by using this concept of conjugates. Now, you might be thinking, well, what do we do if they're, cubed roots? Are we going to have like 3 of them? No, it doesn't. It only applies to square roots. If there's a square root in the denominator and there's another term, In this case, you can see you have 2 square roots in the denominator, but the concept that we're going to use is the same. So even though, there's a square root there and a square root there, we're still going to use the idea of conjugates. Oops. So I look at that denominator and I think, what's the conjugate of the square root of x plus the square root of 2? It's the square root of x minus the square root of 2. Now I can put parentheses because that'll help me when I go to FOIL it. And then I'm going to multiply by the same thing in the numerator. Now in the numerator, I have the square root of 5 times the square root of x minus the square root of 2. I would probably distribute that, but I'll do it later. Okay, now in the denominator, we're going to FOIL. That radical times that radical, that's the first in FOIL. That's going to be just an x. But if you want to write the square root of x squared, you can write that, and then we'll simplify it on the next step. Then you have the outers. They're both square roots. It's going to be minus the square root of 2x. So you can multiply those radicands. Then you have the inners. I'll switch colors, see if that helps. So the inners, that's going to be plus the square root of 2x. Now we kind of knew that was going to happen where we got one positive and one negative. That's the whole point of the conjugates. And then we have to do the last. So minus, because you got a positive times a negative. And then it's going to be the square root of 2 times 2 is 4. Okay, so now we're going to just do some simplifying. I'm going to go ahead and distribute like I said I would this time. And the only reason I'm doing that is because there's all those radicals. I was thinking it might look nicer to have the square root of 5x minus the square root of 10. I don't think any canceling is going to happen even if I had the square root of 5 on the outside. Now, in the denominator, what happens? Well, this is going to be an x. These are going to cancel. And then I'm going to have minus 2. And that's, the 2 came from the square root of 4. Okay, that's it. I don't think anything else is going to happen. So let me write it nicely. The square root of 5x minus the square root of 10 over x minus 2. If you wanted to not distribute the square root of 5, it would look like this. Nothing happens in either case. I don't care which way you have it. Either way. You get a binomial in the denominator, but there's no radical in the denominator. And that's why this problem is simplified, because there's no radical in the denominator. We've rationalized the denominator. Okay, so that one's done.